Lesson 4, Transformations of the Rational Function. So here's a rational function that we've looked at in the previous lessons. So we have f of x equals 1 over x. So it looks like a rational number, except the variable that you're looking at is in the denominator. So for the warm-up, starting with the graph of y equals f of x, describe how the graph of the following function would be obtained. So one thing to remember is that whenever you are looking at transformed functions, the horizontal transformations have to be in factored form. And so I'm going to rewrite this expression as negative 3 f of, now if I factor out the negative 2 in front of the x, so I get negative 2 and then x minus 2 and then plus 5 at the end. And what this helps you recognize is what the appropriate horizontal shift would be. So because this question is just asking us how the following graph would be obtained, it doesn't ask us to describe the transformations. It just asks us for the mapping notation in words. Let's take a look at what we would do to the x values. So here I know I'm going to multiply the x values by negative 1/2. Remember that it's always the opposite when you're looking at horizontal transformation. So this is actually a horizontal compression by a factor of 1/2. So I'm going to multiply the x values by negative 1/2. Then I'm going to add 2 since the graph is shifting to the right 2 units. Okay, in terms of the y values, I'm going to multiply the y values by negative 3. And then I'm going to add 5. Okay, so in terms of the vertical transformations, there's a vertical reflection in the x-axis, a vertical stretch by a factor of 3, and then a vertical shift up 5 units. That gives me this mapping notation in Word. Okay, in terms of the properties of rational functions, so we talked about this before. So for the rational function, you'll notice that there are 2 key points that we really need to look at. One of them are at negative 1 and negative 1, and the other point is at 1 and 1. Okay, so x equals negative 1, y equals negative 1, x equals 1, and y equals 1 as well. In terms of the asymptotes, you can't have x equal to 0 and you can't have y equal to 0, so you actually have a vertical asymptote at x equal to 0 and a horizontal asymptote at y equals 0. In terms of the domain, because all other values of x exist except for x equal to 0, the domain is x is an element of all real numbers, such that x cannot equal 0. Similarly, same idea for the range. Because you cannot have y equal to 0, but you can have all other values of y, you have a range where y cannot equal 0. So some things to remember. For the rational function, will the value of x ever be 0? So what you're essentially looking at is if you plug in x equal to 0, can you actually find a value of the function when x is equal to 0? So if I plug in x equal to 0, I get 1 over 0. And we know that division by 0 is undefined, so we can't actually have a point when x is equal to 0. So what this results in is a vertical asymptote at x equal to 0 because it gives you an undefined result. Okay? Similarly, will f of x ever reach 0? So what you're trying to see is whether or not the function will ever be equal to 0 or if y would ever equal 0. And so if I plug in y equal to 0 or if the function is equal to 0 here, I get 1 over x is equal to 0. And because I know that if you divide 1 by any number, you'll never get a result of 0, what this ends up creating is a horizontal asymptote at y equal to 0. So these are values of x and y that can't exist. And you'll notice that these values can change as you transform the graph by shifting it either left or right, or if you shift the graph up and down. Okay, so the location of your vertical asymptote and horizontal asymptote, you'll notice, will change after we go through this lesson. Okay, transformations of the rational function. When you are looking at the transformations of the rational function, the effects of each transformation are still exactly the same as what you saw from before. So in other words, the values of a, k, d, and c affect the base graph, in this case it would be the rational function, in the exact same way as they affected the quadratic and root functions that we looked at from before. So here is any base function, doesn't matter what the function is. A, k, d, and c, notice the locations of them. K and d are inside the brackets. A and C are outside the brackets. That's how you know the difference between the horizontal transformations and the vertical transformations. Okay. Similarly, if you're looking at it in terms of a quadratic function, you remove the f and you include an exponent of 2, which makes it quadratic. If you're looking at a root function, that was omission. Okay, if you're looking at a root function, you remove the f and instead include a root sign, and you'll notice that the values of k and d are inside or underneath the root sign. If you're looking at the rational function, and this is the one we're going to be focusing on today, you'll notice that the values of k and d are in the denominator where the x is. So for a rational function, the variable x is in the denominator. You'll notice that k, which is your horizontal stretch or compression or reflection, and d, which is your horizontal shift left or right, these are both in the denominator where the x is. The a and the c are either in the numerator or outside of where the rational expression is. Okay, you might also see this written in the form y equals a bracket 1 over k x minus d plus c. You might also see it in this form. Again, a and c are outside of where the x is. So notice that only k and d are in the denominator. Those are your horizontal transformations. A and c are not in the denominator, so they represent your vertical transformations. So let's look at some examples. So for the first example, it says the function y equals f of x, where f of x is equal to the rational function, 1 over x, has been transformed to y equals a f of kx minus d plus c. And then it says express the equation for each of the following transformations in 2 formats. So I guess one of the formats would be the general base function format, and then the other one would be if it was a rational function. Okay, so let's take a look at what the description of the transformations are. So it says a vertical expansion by a factor of 5 and a translation of 3 units downward. So remember, just like we did before, we want to think about which variable this is affecting, and then based on that, write our transformed function and then our rational function as well. So a vertical expansion by a factor of 5 tells me that I'm affecting the a value, and a translation of 3 units downwards tells me I'm affecting the c value since you're shifting the graph down. And so the transformed function would look like y equals, a is going to be 5, f of, notice that there's no horizontal transformation, so f of x stays as f of x. And then because the graph is shifting down 3 units, this is going to be minus 3. Okay, so that's for our general base function. Now if I wanted to write this as a rational function, all I need to do is replace f of x here with 1 over x. So I can rewrite this as a rational function by writing it as y equals 5, 1 over x minus 3. So notice that all I've done here is I replaced f of x with 1 over x. Okay, just like it tells me right at the beginning of the problem. Now you can also rewrite this rational function as y equals 5 over x and then minus 3 as well. That's another way you can write it. So you can either write the vertical stretch as a number at the front, or you can write it in the numerator of the rational function as well. Okay, let's take a look at the next one. It says a horizontal expansion by a factor of 4. So I know that this is going to affect the value of k. A reflection in the x-axis. So that's a reflection going this way. So I know that this is going to be a vertical reflection, so that's going to affect a. And then a translation 6 units to the left, so I know that's going to affect the value of d. Okay, since it's a horizontal transformation. So if I were to write the transformed function for any base function, this would look like y equals, a is being affected, it's going to be negative because it was reflected, so negative f of, and now I know I have some horizontal transformations, so I need to include those as well. So horizontal expansion by a factor of 4 means that my coefficient would be 1/4. And then because there is a shift, I need to make sure I write this in factored form. And the shift in this case is 6 units to the left. So that would be plus 6 inside the brackets. Now if I were to write this in rational form, I'm going to replace the f with 1 over x, but I'm also going to replace the x with 1/4 x plus 6. So this is the entire denominator part that I'm going to be looking at. Instead of just writing x, I'm going to write 1/4 x plus 6. So as a rational function, this would look like y equals negative 1 over 1/4 x plus 6. Okay, and the negative should either be right in the middle at the front, or it should be in the numerator part, since it's a vertical reflection and not a horizontal reflection.